Uh, Sir, good evening. This is Dr. Sunita. First of all, I would like to thank you for such a lovely presentation and the method of teaching. Really loved it. But there was a voice breakage in between and where we could not hear you. So could you just explain I think, initial slides where you were correlating the ECG and the Doppler mapping with that? Could you just explain that slide, sir, once again? It's not
Uh, no, this one, this one.
Next one, sir. Next slide, sir.
Uh, See what we said at ECG.
this, sir.
Perfect.
This one, sir. This one.
From the QRS complex to the T wave is the systole. From the T wave to the QRS is diastole, and this is the P wave also. So they will be very helpful in finding out the timing, various arrhythmias, rate, heart rate, atrial fibrillation. We always keep it. So this is systole, and this, if you take an original ECG, from the QRS to the T wave is systole. From the T wave to the next QRS is diastole, and diastole is always longer than systole. And this is the P wave, which is the atrial contraction. This was told to you. Now, this is what we told you, that you see, once you see diastole and systole. Now, this is mitral valve. This is anterior mitral leaflet. This is the posterior mitral leaflet. They open in a reverse direction and then they meet and close in systole like AV wall. So the diastole is shown again by the end of the T wave up to the QRS complex, and the closed systole is shown from the QRS complex to the end of the T wave. And this is, of course, you see a ventricle contracts in systole and dilates in diastole. Now you see here is the LV dilatation which is occurring in diastole, and this is contraction which occurs in systole going from the QRS to this. So these are the some of the things. Everything was say there are many things. This is ejection of the blood, and that is why the muscle thickens in systole, and that is why the once you can get this. Anything else?
Thank you so much, sir. Thank
Now
you.
you have to read it, because there I know there will be certain confusions also, but you have to read it, and then it will become, at some stage it will become, say, when we used to have a regular courses, the doctors used to come with a phobia of Doppler, and believe me, from next day they themselves started doing a Doppler. I have never read a Doppler physics in last 50 years. I can never understand it.
Sir, you are a master
Hello.
doctor person, sir. Dr.
Many,
Ajit
because
Dengle.
it is such a difficult thing also.
Dr. Ajit Dengle to ask a question next.
Yes, sir. So good evening. Thank you for the wonderful lecture. Just wanted to ask, can you please elaborate a bit on the raising the gain and reducing the gain part?
Pardon? What did you
Regarding the,
say?
can you please elaborate once again on the gain part?
Sir,
Yes,
gain
so
question, sir.
there are two types of gains. One is an overall gain, and one is a TGC, time gain compensation. The overall gain has got a 2D gain, Doppler, and a color flow mapping. The overall gain increases the whole intensity of the particular structure, and your decrease gain produces a very low disturbance thing or so. And one is a TGC, which is selectively acts at a certain area. Suppose you want to see a certain area, then you use a TGC, because if the TGC is quite high, then many of these overnight come also. So the total gain is affects the whole echo picture. A TGC, a time gain compensation, there are multiple buttons which act at a certain level or so. So they will be told to you during the live demonstration to be done there.
Okay, sir. Thank you. Thank you very much.
Sir, myself, Dr. Kumar.
Vidwar, go ahead. Ask the question.
Sir, I have some basic question about this the Doppler wave, the approach to study Doppler. But why should can you please revise the concept of approaching Doppler above the baseline or below the baseline? What difference does it make if I plan to study it the opposite way? And what is difference between the Doppler shift and studying Doppler wave?
This Doppler shift is something different. Now here what we do, this is mostly helpful in the, now this is the baseline. Now when you put the baseline above, the velocity down below the baseline increases. You can see up to going up to this place. So suppose there is a mild physiological aliasing. By increasing the velocity scale and by shifting, suppose there is an aliasing like this in MR, then you it in above, not MR, but
Yes, sir.
any of the, depending on which valve or so. And when you shift it below and the above it, so in the above opposite direction of the shift of the baseline, the velocity increases. So that is sometimes we use, so once there is a physiological aliasing, thus now for this is 0.5, or let us come here, this is 1. The 1 can be increased to 2 or 3, some some of the new instruments also, so that they themselves increase the velocity. If they do not have that facility, then you increase it, and in the direction opposite the baseline shift, the velocity increases. Now here the velocity is here because you brought it down, the velocity above increases. So these are mainly helpful in a physiological type of aliasing, not in a pathological aliasing.
Okay, sir. So, sir, is there any guideline to set this well upper limit in
No,
personal?
no. This guideline is only that, say your aim is to bring it above 1.5 to 2 meters per second. But sometimes doing this also may not help you. An increasing velocity scale may not help you, but in a small minor aliasing, this will help you. Otherwise, go straight to the CW Doppler.
Okay. Thank you, sir. Thank you. Thank you. Thank you very much.
Sir, may I add a little bit to this? Because if you have a person whose normal velocity is up to 1.7 meters per second, you keep your Doppler scale of Doppler flow close to 2 meters per second. Look at this Doppler slope seen on the right side of the screen. This
Yes,
is
sir.
1.5 and 0.5. So it's almost 2 meters of a Doppler scale.
Yes, sir.
If a forward flow maximum flow velocity is 1.3, that is mitral, and down blow is 1.7 of aortic. So keep this scale around 1 meter on this side, 1 meter on this side, and that will really help you out.
Sir, just out of interest, I have some query. Suppose their aortic in high velocity, it is by it should be continuous wave Doppler. So is it not possible to set the velocity limit to 6 and then use pulse wave Doppler?
No, the continuous wave Doppler, your question is that it is a disease flow, correct?
Yes, sir.
You can set, you now suppose there is a CW Doppler you have put. Even
Yes.
by putting a 4 meters per second, it is not coming within the whole velocity scale. Make it 5. So depending upon the velocity, the main thing is that whole velocity profile should be available into the
Okay.
in
Yes,
this
sir. Got it, sir.
in the now you see. Now here what you see the velocity 5.7. Now suppose
Yes, sir.
here you have kept it at 4. It would not have come into the whole area.
Yes, sir.
So the whole velocity should be seen in the velocity in the Doppler pattern. So we have gradually increased it, brought it going up to 6 or so, because it is about 5.7. Now if you keep up to 3, the aliasing will still continue because you cannot see the apex. So the whole Doppler envelope should be well seen. And that is why you adjust the Doppler in such a way, velocity, that the whole Doppler envelope is seen. That is the whether it is 3, 4, 5 or anything.
Thank you, sir. Thank you very much. Thank you. Got it.
Dr. Rajesh Gaude. Dr. Rajesh, you wanted to ask something? Dr. Achal?
Yes, sir. Sir, actually, my question is regarding Nyquist limit. I'm not sure if it will be covered in future topics.
No,
But it
go
has
ahead,
been-
ask your question
Say,
right now.
say the Nyquist limit has been set up. Now, I'll not go into the physics of Nyquist limit, which is very complicated.
Yes, sir.
Nyquist limit is the maximum measurable velocity by a pulse Doppler beyond which aliasing occurs. So suppose the aliasing occurs at 1.7, so we say the Nyquist limit is 1.7. So there is no Nyquist limit in CW Doppler. The Nyquist limit is only in a pulse Doppler where you find that there is a maximum measurable velocity of C. So that is the limit of a pulse Doppler echo. So you can vary it. There are various methods also.
Hmm.
Now we have got high PRF also values which can give a velocity be up to about 3 meters also without any aliasing.
But sir, in color flow mapping also there are options to adjust the like on the right side top that we can
A
see.
color flow mapping is based on the principle of a pulse Doppler.
Hmm.
So that the aliasing also occurs in a color flow mapping because it is again based on the pulse Doppler. So that is why, and there is a slight change in the color in those cases.
Because sir, adjusting that changes the lesion completely.
There is a slight change in the color. It becomes slightly pale here, blue here. So there is an aliasing in the pulse in the color flow also because, and that again we adjust by the velocity. So this is again based on a pulse Doppler equipment, a pulse Doppler also.
Okay.
So you can get aliasing and then you can gradually increase the, see, all this confusion will be cleared very soon when you start doing it yourself or you see somewhere else also.
Okay.
Aliasing is a phenomena of pulse Doppler. And because this color Doppler, which is in color, which is overshoot on a 2D echo, also shows a pulse Doppler. So it can also show some aliasing.
Okay. Thank you.
Sir, can I ask a question, please?
Dr. Nathan, go ahead.
Sir, why do we get the envelope only below the baseline? What is the situation, sir? Why not above the baseline in the color flow or the color Doppler?
Is it not above the baseline?
No, sir, the envelope for AR and MR.
AR, anything which goes below the baseline. Any flow which is going below the baseline is the going away from the MR is going away from the transducer or not?
Yes, sir.
Eh? Now you see, this MR is from the mitral ball. The MR goes into LA or not?
Yes, sir.
So now it is going away from the transducer.
Yes, sir.
Transducer is always pointing from above downwards.
Yes, sir.
So it is going away from the transducer, so it is negative. And similarly, if you see, now see here, this gives you everything. Now you see this is below the baseline, aortic wall in systole, so stenosis, and this is above the baseline. Remember, any flow going towards the transducer is above the baseline. Any flow going away from the transducer is below the baseline.
Sir, once more, I'll just take down.
तो आज आप ये कर रहे हो, tomorrow you'll yourself say very easy. So the advantage is that if the blood flow direction is such which is not expected, then you If the blood flow direction is such that it is not expected, that gives an idea.
Sir, away from the transducer is a positive.
No. Away from the transducer is negative.
Yes, sir. Got it, sir. Thank you.
Transducer is always pointing above downwards. Towards the AR is always towards the transducer or not? From aorta to LV, the AR comes from aorta to LV, correct?
Yes, sir.
It comes from aorta to LV now.
Yes, sir.
And it comes in diastole. You see in diastole it comes above the baseline.
Yes.
Towards transducer, positive, away from transducer, negative.
Thank you, sir. I got it.
Sir, can you hear me, sir?
Is that clear, Dr. Nathan?
Yes, sir.
Okay, anybody else?
I have a question, Dr.
Dr. Sanjeev Mathur. Sanjeev, go ahead.
Dr. Parasha, thanks for the great talk. Can you tell us a little bit about the scale which I see in this slide? You know, there is a scale, and how do you correlate
This is the scale. You see the velocities above the baseline. And
I'm sorry, sir, not this scale. The color flow scale over on the top.
Nyquist limits.
No, on the same slide. Go back to the same slide. Yeah.
This Nyquist
The
limit.
green and the green and the colored scale on the side. This one.
this
Back
is
to the same
always
slide.
shown on the color flow map. This is always shown. And once you
The scale, sir, on the right side corner, on the right corner, the scale. How do you correlate it with the flow?
on
the right corner, yeah, on the top right.
For example, it is 0.59, 0.60 here, correct? Now, for example, in certain valvular regurgitation, we keep it at about 0.54 or so. If you find that it's a very disturbing flow, which you cannot see, then you can slightly increase the velocity scale here. The Nyquist limit here you can see both above and below the baseline. Below is below blue, above is red or so. So these adjustments can be made depending upon the case-based method also. Because there are certain limits. We may start with 0.72. But ultimately, it is normally available at about 0.54 to 6 or 0.6 or so in all regurgitant cases. Now, if you keep it very high, then you will miss certain regurgitant. So then a regurgitation will become mild if it is kept at 0.72 or 0.8. But the same regurgitation can be moderate when you keep it at the correct level or so. This will all be shown, then you'll be more clear, but you must read what has been shown and you can.
Sanjeev, bear with me. I'll show you all these things one by one, and then I'll be able to solve your queries also. Because this is Nyquist limit is, if you put on, this is a Vibgio scale, violet, indigo, blue, green, yellow, orange, red.
Right.
So if this scale is blue in color, from this point, like if you look at the blue top and a blue bottom, look at the color is changing from dark blue to light blue.
Right.
As the velocity is decreasing or velocity is approaching towards -60, the color is changing. That's what I'll try to show you when I show a live demonstration. Give me some time before we put a live demonstrations.
Sure, sir. Thank you.
Okay. Dr. Gowda, you want to ask something?
Yes, sir.
Go ahead.
Sir, in aliasing, the width of that positive aliasing will be that is the gradient, sir?
No. Of the... Say the aliasing you see. In aliasing, you cannot measure because from where it is starting, from where it is going, you don't know.
Okay, sir.
That is why now you see this. Now you don't know from where to start, where to end, because as I told you, in the basic thing, there should be the whole of the Doppler envelope should be seen. Now here the Doppler envelope is cut here and cut there, so you cannot measure it. So we have to bring that down. Now you see the whole is velocity is seen, correct?
Yes, sir.
So the advantage, so here that's what the problem with the aliasing is this.
Okay, sir. Okay. Thank you, sir. That is the gradient, sir? If we see full aliasing?
That is the difference between LV and LA pressure. ये तो ये सब आपको बताएंगे. Don't go on the first day.
Okay, sir.
Look,
All
aliasing.
depends upon the driving force. If the LV function are poor, it may be less or so. So the aim is that your whole Doppler envelope should be seen in your study here. Now here it is not seen. You can measure the mitral velocity, forward velocity, but this you cannot measure. So basically the whole Doppler envelope should be well seen.
The
Okay,
word
sir.
And by the color advantage is that we can put it parallel to the flow.
Yes, sir.
the word
Okay, sir.
turbulence is for color flow. The word aliasing is for Doppler flow.
Okay,
Just
sir. Okay,
remember
sir.
these two words. They are two different words.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Anybody else?
Hello. Hello, sir.
Identify yourself, Dr. Oja.
Yes, sir.
Go ahead, Oja.
Sir, yes, very excellent deliberation, sir. Sir, can you elaborate the functions of the different control panels on the Doppler study?
No, as I told you, this you can understand better once you are shown the yes. Once you are shown the cases, for example, we see Doppler gain, we see wall filters, velocity scale, baseline position. So this you will understand much better when you see the live demonstration. For example, you see here the gain is more, here the gain is less. Then you see here everything is at the baseline. If the filter is high, this is cut off from here, so you don't know from where to measure. If the filter is low, it is very advanced. It is very sort of a disturbing thing also. So I think this will be better understood by you when you see a live demonstration of a gain, ball filter, velocity scale also.
I think, Dr. Oja, what we can do is next Friday, we can keep a live demonstration of all these modalities, including knobology.
Okay, sir. Okay, sir.
If
Right.
everybody
Okay, sir.
agrees, just put on a
Okay, sir.
WhatsApp group. We'll keep on Friday so that 5 o'clock onwards, we'll take 2 to 3 hours class because I have to mobilize a complete people for this live demonstration. Three to four people has to be there. 5 people has to be there.
Okay, sir.
So we'll do a
That's right.
live demonstration on that day and they'll explain everything. And I'll request Parasha sir also to join at the time so that he'll be able to have a comments or his wisdom or his experience to talk about all these points. I'll be showing live.
Does Friday suit you people?
Sir, it will suit because ultimately live
They
demonstration.
have to.
I have to have only 4-5 people on.
You have to sacrifice your practice to learn a new technology.
Yes, sometime I'm sacrificing my practice today. I'm there in the center only right now. Okay, so we'll keep it on Friday there.
Okay.
Anybody else?
May I?
Saurabh, go ahead.
Yes, sir. Very good evening, sir. It's an honor to interact with you. Sir, you mentioned we use pulse wave Doppler to calculate regurgitant volume and color continuous wave Doppler.
That was one of the, say, just remember one thing, whenever you want to study a specific thing, put a pulse Doppler. So whether it is a regurgitant, so I have not added this regurgitant volume also will be told you during the MR and ER lecture also. So because it is, we have to measure, remember one thing, once you have to measure a specific site pulse Doppler. I showed you, for example, LVOT pulse Doppler. Yeah. And when we measure LVOT diameter, parasternal long axis. So these things will come once you start reading.
Okay. Thank you.
After next Friday, you will be much wiser.
Anybody else?
Hello, sir. Sir, what is LVOT flow, sir?
LVOT means left ventricular outflow tract. Every chamber has got an inflow, apex, and outflow. As the name indicates, outflow means that the blood has to go out of the left ventricle and that means the LVOT is known as left ventricular outflow tract, which is just near the inflow toward the mitral wall. That is inflow. The blood in the LV goes into 2-3 to the mitral wall, correct? To the LA. So that is LV inflow. The blood goes out from the LV into the aorta. So you have to read your basic anatomy that with what is aorta, what is LV. So when the blood has to go through the aorta, so that means the LVOT is just below the aorta. There's a lot of functions of the LVOT being used also. So Shadab
Thank
sir,
you.
when did you last read, open a textbook or anything?
Okay. Thank you.
5-10 years back, because you don't know from how the blood goes out of the LV.
Sir, what happens if we use a continuous wave instead of a pulse wave at the normal valve?
Nothing much. Say, but say if you are using a CW called a normal valve, you have to reduce the velocity scale quite a bit also. So if that is why I told you that the sequence is always pulse wave and the CW. So if you are using a normal ball, you always get a better envelope in a sheet of a pulse Doppler. In a CW, the whole Doppler is filled up. The whole Doppler tunnel is filled up. But so suppose you are studying a case of a normal ball, suppose the velocity is hardly about 0.5, 0.6, it will be clustered together. So the better slope, better velocities are seen from a pulse Doppler. You see a CW, you see that all the echo free spaces are filled up with the echoes also. So there will be no problem.
Yes.
But there are certain uh, things which will help you in better seeing also. Now
Sir, do
if
you
you
have a
take a
slide showing that?
if you
Sir,
take a CW, you
yes,
see
sir.
that this is a pulse Doppler. You see this is all very well seen and the edges are very well seen. If you see a CW, this will all be filled up because it is interrogating right from pulmonary vein to LA to LV up to the apex also.
Oh, yes, sir.
So you
Okay.
cannot get such a good Doppler envelope as compared to a pulse Doppler.
I got it, sir. Thank you.
Any other questions?
Yes, sir. Sir, how can we have a view with pulmonary artery parallel to the transducer?
Pardon?
So how can we have a view to see pulmonary artery parallel to the transducer in order to measure that gradient along that
Across
pulmonary?
the
Hello?
across the
Across the pulmonary valve, sir.
uh,
How
so
can have a view that you were showing again and again, na? That pulmonary artery by the side of LVOT. How can we have that view, sir, on echo machine?
the LVOT is different. Say,
Yes, sir.
so you see this is the pulmonary artery.
No, in one view, you were saying that pulmonary artery is just parallel to the transducer, sir.
So you see the pulmonary artery flow is parallel to the transducer.
Yeah, in order to have that Doppler, sir.
Huh?
In order to have Doppler.
So you see that is why we take this into this view. If you put a Doppler here, it will be parallel. It will be almost parallel to the flow.
Sir, you were showing one more view, sir. That was our question.
Eh? I
For
said sometimes you can I can show you the slide someday. You can see a nice pulmonary artery from the subcostal view.
Anuj, at your
Very nice
level,
pulmonary artery.
Anuj,
And
at your
many
level,
times,
remember this only. That's all.
and then we can use you can use this RV outflow tract.
Anuj, at your
RV
level,
outflow.
remember.
There is an RV outflow view. There are many views. The subcostal view I will show you the next time. A beautiful pulmonary artery from the subcostal view.
Sir, I think at their level, this is more than enough.
Yeah, that is why I have not shown. I have only shown them this one thing.
Anybody else? Two more participants.
What was the name of the lady whose English is very good?
Sunita call.
Eh?
Sunita call.
हाँ. Sunita, can we see your face?
Anybody else has got a questions?
Yes, sir. I'm here, sir. Good evening.
Because so you are based where?
She's
You have to
working.
unmute yourself.
She's working in FMRI in Gurgaon.
अच्छा, Gurgaon.
And she's an ardent fan of Dr. Samir Srivastava.
Eh?
She is an ardent fan of Samir Srivastava.
अच्छा. Then you should have gone to maths.
Basically, I was there to learn an ECMO program, sir. So after that, I would just continue in the department.
Good. Chalo, I'm sure you will have it. All of you must read. You have got 1 week there. Unless you know all the views, and the 2 lectures should be seen by you within the next 24 to 48 hours. See what are the views and how can you get it. All your query about Doppler and color will be solved once you know that which structure is seen in which view, what are the structures.
Okay, anybody else want to ask some questions before we call it down?
Sir. Am I audible, sir? Good evening,
Yeah,
sir.
please, Rohtas Singh, Kalsi.
So can we have the slide where the aliasing is shown, sir? Can you please show us again, sir? With the slide where aliasing is shown, sir. There is a specific slide in which aliasing was demonstrated, sir.
Aliasing आपको हम लोग Friday को दिखा देंगे.
सर माइटर डॉपलर स्पेक्ट्रल फ्लो का स्लाइड है आपका सर, जिसमें एलियासिंग दिखाई दे रहा है सर.
Now this is aliasing.
Yes, sir.
So here you see we have purpose. This is a case of mitral regurgitation. We have purposely put a pulse Doppler here. Purposely put a pulse Doppler to show you aliasing. And then when we put a CW Doppler, aliasing disappears.
But sir, like, can we see the previous slides? Yes.
Yeah.
So how do we know that this is aliasing and not, like, as you had mentioned, sometimes we get a mitral stenosis with mitral regurgitation. How do we know this is?
So even if suppose for the sake of it is again, when any flow is both above and below the baseline and is cut, that is the aliasing. Now suppose it is mitral stenosis with regurgitation, correct? So
yes,
what is the severity of the regurgitation? What is the velocity of the regurgitation? So we have to, aliasing, the purpose is to show you that once that a pulse Doppler can produce an aliasing which disappears by the CW Doppler. So here what we can do, we know the velocity is 5.7, the difference in pressure is 130. So that is the aliasing also. That aliasing means that it is an increased velocity which cannot be picked up by the pulse Doppler.
Right, sir. Thank you, sir.
Anybody else? No questions, no more questions.
And when you read, I say, whenever you read and you are not, something is not clear, you immediately send an email and the clarification will be given. If a thing is not clear to you, suppose the pulse and CW Doppler or anything is not clear to you, then how can you read further? We have not shown you any quantitations yet or so, but the only thing is that you should read both the chapters and both of them are interlinked.
Sure, sir.
All right, friends, if there is no more questions, can I take your attendance today? Anybody can say yes or no?
Yes, sir.
Okay. Dr. Pranjal Jagtap said yes. All right, sir. Can we stop sharing our slides, sir?
Please.
Thank you, sir. Thank you very much. We'll be sending a Doppler book to everybody, and these lectures plus Doppler book would be more than enough to begin with. And we have with us one of the Doppler book of test book of Indian Academy of Echocardiography. It's a huge Doppler book. I can show you right in front of me. It's lying with me. Just hold on. I'll show you like. This is just a Doppler book. You can buy from JP Brothers. And Dr. Parasha is one of the editor-in-chief of this particular Doppler book. And this is only very small size. So
but they'll find it as a useful book if they can take.
Yes, certainly. If you read, it'll be really, really useful book. Second thing is, at this particular moment, my submission is listen to these talks again and again. We'll be sending another book, which has been also partly written by Dr. Parasha sir. And that Doppler book would be most useful. And some Dr.
And by me and Rakesh, not Dr. Parasha, both of us.
And Eco Made Easy is a gutka. If somebody knows the word, what is gutka is, Eco Made Easy is a gutka. So that's not a real standard book for learning echocardiography. We'll be sending you another Doppler book very shortly. Give us a breathing time. So I'll start with the attendance of Dr. Nitin. I could see Dr. Nitin sitting over here and he asked a very beautiful 2 or 3 questions. That was lovely, Dr. Nitin. Then Dr. Pratibha Dhingra. Dr. Pratibha, you have to say yes or no. Dr. Pratibha Dhingra. So I couldn't see Dr. Pratibha Dhingra. Dr. Virvar Kumar Jha did ask one question. Dr. Ankit Seni. Dr. Ankit Seni, are you there? Dr. Shashank Sunil Tuse. Dr. Shashank. Dr. Shivaji Vithova Mali. Dr. Harshvardhan Puri. Dr. Pallavi Horo. Pallavi, say yes or no?
Yes, sir.
Yes, that's good. Thank you. Dr. Anchal Dikshit, she was present.
Yes,
Dikshit asked one question. Dr. Saurabh Gupta was present. He asked one question.
Yes, sir.
Dr. Avinash Solanke.
Yes, sir.
Dr. Sangeeta Chaudhary. She is there. She's.
Yes, sir.
I could see Sangeeta. Dr. Ashok Yadav. Ashok Yadav.
Yes, sir.
Ashok, show your face. Where are you right now, in Fortis or somewhere else?
No, sir.
पढ़ रहा है ना?
Sir.
Dr. Birata Devarama. Dr. Birata
Yes, sir.
Devarama.
Yes, sir. Yes, sir. Present.
No, this is Bhim Raya. Bhim Raya.
Oh, okay.
No,
Yes, sir.
I'm asking Birata
Raya.
Devarama.
Okay, sir.
Dr. Venkatesh Gowda did ask one question. Dr. Piyush Mahendra Pandey.
Present.
Dr. Pankaj Mishra.
Yes, sir.
Dr. Ajit Balasao Dangle.
Present, sir.
Dr. Kiran Vasantrao Birari.
Present, sir.
Rohtas Kalsi. He did ask one question.
Yes, sir.
Sandeep Kumar.
Yes, sir. Yes, sir.
Prabhakar Gupta. Prakhar Gupta. Prakhar, are you there? Chitranjan, Dr. Chitranjan Thati. Dr. Sardana Prasanna Sahu. Sarada Prasanna Sahu. Dr. Prasanna Sahu, are you there? Dr. Subhash Chandra. Dr. Subhash. Dr. Subhash, are you there? Dr. Sofinur Islam.
Yes, sir. Present, sir.
I couldn't see you, Dr. Sofinur.
Yes, sir.
Okay, got it. Dr. Pranjal Prakash Jagtap.
Present, sir.
Pranjal is there. Dr. Deepak Suman. Deepak Suman. Dr. Rupali Sawant.
Yes, sir.
Archana Kishore Sinalkar. Madhurima Datta.
Yes, sir.
Mahesh Padsalge. Mahesh, are you there? Dr. Bhagat Vibhusha Vishwanath.
Yes, sir.
Dr. Dheeraj Kumar Singh.
Yes, sir.
Dr. Sanjay Mathur was present. He did ask one question. Dr. Niranjan
Yes, sir.
Agarwal.
Yes, sir.
Dr. Bhimaraya is there. Dr. Rajesh Gudade. Dr. Rajesh Gudade. Rahul Kumar.
Yes, sir.
Dr. Karthikeyan. Dr. Karthikeyan. Dr. Ravi Gupta.
Yes, sir.
Dr. Subhash Chandra. Dr. Subhash. Dr. Khushpreet Singh. Dr. Umesh Oja was present. Dr. Amit Vikram. Amit Vikram. Rajshri Karat. Rajshri
Yes, sir.
Karat. Yeah, okay. Raj Rajendra Borkar.
Yes, sir.
Swapnil Datta.
Yes, sir.
Parveen Kumar. Dr. Parveen Kumar.
Yes, sir.
Prashant Pandey.
Yes, sir. Dr. Praveen Kumar.
Parveen Kumar is fine. Dr. Prashant Pandey.
Yes, sir, in attendance.
Okay. Prasanjit Kumar Pandey. Dr. Ravi Kumar Singh.
Yes, sir.
Hello.
Ankit
Dr.
Agarwal.
Prashant Pandey present.
Yeah, I've done it, Prashant. Ankit Agarwal.
Sir, Dr. Ravi Kumar Singh, sir, present.
Yeah, done it, done it.
Okay, sir. Thank you.
Ankit Agarwal. Dr. Sanika Sachin Kadam. She is there.
Present, sir. Yes,
Anuj
sir.
Kumar. He asked a question. Deepak Kumar.
Yes, sir.
Niharika. Dr.
Anuj Kumar
Niharika.
present, sir.
Yes, sir. Yes, sir.
Good, good, Niharika. Thank you. Dr. Vivek Kumar Dwivedi. Vivek Kumar Dwivedi. Narendra Agarwal. Narendra Sharma.
Yes, sir.
Devendra Pratap Yadav.
Yes, sir.
Muhammad Iqbal.
Yes, sir. Present, sir.
Shahadab Reza. He is present already.
Devendra
Yes, sir.
present, sir.
Present, sir.
Anuj Jain. Anuj Jain. Aarti.
Yes, sir. Present, sir.
Aarti Jadhav.
Yes, sir. Present, sir.
Santosh Kumar.
Present, sir.
Dr. Sunita Kaul was present. Parvesh Kumar Alwani.
Yes, sir.
Parvesh.
Present, sir. Sir, it's Paresh.
Paresh.
Thank you, sir.
And Dr. Prasanjit Panda has come back. There was Prashant Kumar Pandey. Prasanjit has marked for Prashant.
Sir, Dr. Shashank Tuse present, sir.
Prashant Tuse has come back. Okay.
Shashank Tuse present, sir.
Dr. Sheetal Bodke.
Yes, sir, present.
Dr. Ritika Terhan.
Present, sir.
All right. Anybody else left?
So Dr.
Sir,
Pratibha
Dr.
Dhingra.
Prakash.
Just a minute, Shashank to say, Doctor.
Dr. Shashank to say.
I've marked you question.
So
Anybody?
Dr. Pratibha Dhingra.
Pratibha Dhingra. Pratibha, I did call your name in the beginning and you did not respond.
Sorry,
Okay,
Sir, Dr. Prakash.
Dr. Prakash.
Yes, sir.
I marked you already present, Prakash.
Sir,
Okay, sir. Thank you.
my name is Iqbal Mahmood, sir, and your auntie is Mohammed Iqbal. So sometimes I get confused. Iqbal Mahmood.
Muhammad Iqbal. What's your name?
Iqbal Mahmood.
Iqbal Mahmood. Okay.
Yes, sir.
So what I'll do, respect to everybody, just call it out. Send your email ID, your telephone number, and your correct name on the WhatsApp group.
Yes.
Okay.
Sir, Shashank to say is present.
Yeah, measure to the Shashank. I measured to 3 times present.
Yeah,
Morning,
okay.
afternoon.
Yeah, okay. Thank you,
Yes.
sir. Thank
Sir, in the previous lecture, I had been marked absent, sir. So has it been corrected? Just want to correct.
Anuj, you
Yes,
were
sir.
present in last lecture?
Yes, sir. But in the list we received on WhatsApp, sir, it was marked absent.
Okay, I'll just check it.
Sir, Virvar Kumar Jha present, sir. My connection-
Virvar, I marked you already present. You were present in answering the question.
Thank you, sir. Thank
So
you.
once you ask a question, it means you're already present. Okay,
Sir,
with
Sandeep
this,
Kumar.
Network issues.
Sandeep, I did call your name. You did not respond at the time.
Sir, I respond 2 times.
So I'll mark you twice, right? I'll do that, Sandeep.
Thank you, sir.
Okay, guys, thank you very much. And we'll meet you again on coming Friday. Some people are asking for Sunday. Live demonstration, I have to mobilize a complete machinery. I need to have a subject. I need to have a machines, then audiovisual people. Many of them has to be there to show a live demonstrations.
Sir, one question I have to ask.
Yeah, go ahead,
Hello.
Dr. Rupali.
So I'm Rupali. I'm not doctor actually.
Okay,
Rupali Savanth. And sir, for Friday it is very difficult to attend the lecture for us because we have our duty timings and duty. So can it be possible for Sunday, sir?
Rupali, problem is Sunday we don't have enough staff over here.
But Friday, sir, after 6 it is very difficult. At least give us permission to attend our use our mobiles because laptop is very difficult.
After 6, laptop is not available. That's what you mean to say.
Means we are traveling or we are in hospital. We were in hospital that means we are in hospital that time.
So, well, the problem is like whenever we see